For question 4, I'm going to take the limit as h approaches 0, and our function is x squared. So we'll have 2 plus h squared minus 2 squared over h. And this I can take a little bit further. This is the limit as h approaches 0. I know the quantity 2 plus h4 is 4 plus 4h plus h squared minus 4 all over h, which gives me the limit as h approaches 0 of, let's see, I think I'll factor a 4 h out of each of those terms. So I have 4 plus h over h. So then, as long as I'm just taking the limit as h approaches 0 of 4 plus h, suddenly this is no longer in indeterminate form. So that's going to be a 4. And let's see what's going on here. It looks as though I'm looking for the slope of the tangent line at x is equal to 2. Well, I don't know if that is a slope of 4, but it definitely is a positive slope. So that makes a little bit of sense. Let's try the same thing over here. We're looking for the limit as h approaches 0 of x is negative 2. So I have negative 2 plus h squared minus negative 2 squared all over h. And this is going to become the limit as h approaches 0. Let's see, negative 2 squared is positive 4, but then we'll have minus 4h plus h squared minus a positive 4 over h. The 4's cancel out. I can also factor an h out of both terms, which gives us negative 4 plus h over h. So in this case, if I take the limit as h approaches 0 of negative 4 plus h, that in fact is negative 4. So what we are saying is that when x is negative 2, the slope of the tangent line is negative 4. And I don't know if that's a negative 4, but it is most certainly a negative slope. Inverse tangent. So we're going to take the limit as h approaches 0 of inverse tan of 1 plus h minus inverse tan 1 all over h. Well, I do know inverse tan 1 is pi over 4, but that's about as far as we can go. The limit as h approaches 0, inverse tan 1 plus h minus pi over 4 all over h. And we are looking for the slope of the tangent line at x is equal to 1 right over there. So I know it's positive, but this isn't really giving me any information. For question 7, however, we're looking for the limit as h approaches 0 of 2 plus h cubed minus 2 cubed all over h. And again, this is something that, if you remember Pascal's triangle or the binomial theorem, I know this is going to be 1, 2 to the third, plus 3 times 2 squared times h, 3 times 2h squared plus h cubed, and then we'll have minus 8 all over h. 1 times 2 to the third, that's really an 8, so that cancels out. I'm going to factor out an h while I'm tidying this up. This is going to give me 12 plus 6h plus h squared all over h. The h's cancel out, and if I take the limit as h approaches 0 of what remains, that's going to give me a 12. So at x is equal to 2, the slope of the line tangent to x cubed, the slope is 12.